Hi. One of the students asked a question which was a multinomial theorem question, and I wanted to solve this doubt. For this question is quite tough. So let's discuss this. Find the number of distinct terms in the expansion of 1 plus x power 7 plus x power 13 to the power 100. So the idea is obviously the powers will go from 1 plus another term would be some constant and x power 7, and another term would be x power 13, and so on. And the highest power term will be x power 1300. So this becomes a 1300-degree polynomial, but there are some missing terms. Not all the terms here will be there because you have to get powers only x power 7 and x power 13 are there. So combinations of x power 7 and x power 13 will give us the terms, right? So number of terms is not 1301. It will be less than that. And some terms will be missing. And that is what we have to find here. There is some advanced theory by which this can be done with a formula, which is the theory of semi-groups, but that is not in the JEE syllabus, so we cannot discuss it according to that. That is actually much easier to do through semi-groups. However, what we will do here is multinomial theorem. So anytime you have an expansion like this, the general terms will come out like this: 100 factorial by a factorial, b factorial, c factorial, 1 power a, x power 7 power b, and x power 13 power c, right? So this general term looks like 100 factorial by a factorial, b factorial, c factorial, x power 7b plus 13c, and 1 power a becomes 1. And here a plus b plus c is equal to 100. We have to find how many such terms are there. Basically, that means we have to find how many different outputs will 7b plus 13c take. So what are the possible outputs of this, possible values of 7b plus 13c, when we know that b and c both are between 0 to 100. So this is the restriction on b and c. Both are between 0 to 100, right? Now, you have to realize one thing, there will be some repetitions. For example, you can take B as 6 and C as 0. For example, if you take A as 94, B as not 6, B as say 13. What I'm saying is A is 87, B is 13, C is 0. This gives us the power of x power 91. However, you get the same values if you take B as basically 0, C as 7, and A as 93. Think about it. C7 would give us x power 91 term here, and B is 0 will give us 0, and A 93 can be adjusted. So this is the coefficient of x power 91. This is also going to give us x power 91. So there are repeated terms here. X power 91 is coming also in this triplet and this triplet, right? So we have to figure out a way to understand when does this kind of thing happen, right? Similarly, if B is 14, again, you can get a repetition. So what I will show you first is whenever there is a certain situation happening, there is a repetition of terms and those terms will be combined, right? We need to exclude those repetition terms, right? So if you think about it, I need output values of 7b plus 13c, right? And my conditions are 0 is less than b comma c less than 100, right? Now, if b is greater than equal to 13, right? And c is less than equal to 93. In that case, we can take new variables. We can take new variables b1 to be b minus 13 and c1 to be c plus 7. B1 is B minus 13 and C1 is C plus 7. And let's take the value of the pair B1 C1. B1 C1 gives us what? 7 B1 plus 13 C1. That is equal to 7 times B minus 13 plus 13 times C plus 7. And that is going to be 7B plus 13C minus 91 plus 91. So this is going to give us the same value, right? What I'm saying right now is if you have 7B1 plus 13C1, it is going to give us the same value of 7B plus 13C. So if B is greater than 13, you can replace B with a new variable B1, which is less than 13, and adjust C accordingly. C1 will become C plus 7, right? So for example, if B was 15 and C was 85, the value of 7B plus 13C is the same as if B1 was 2 and C1 was 92. So basically the pairs 0, 15, 85 for ABC give us the same value as 6, 2 and 92, right? So anytime your B exceeds 13, we can convert it to a lower value of B. We can convert it to a lower value where B is less than 13, B1 is less than 13, right? And adjust it. So that gives us a hint that we don't need to cover cases where B is greater than 13. We will only discuss cases where B is less than 13. And if you have these cases and you have B plus C less than equal to 100, these cases will cover every possibility. Because anytime B becomes bigger than 13, you will always ensure that you can convert it to a lower case. You can take any possibility. B is 19 and C can be anything. Let's say it is 78 and A is 3, right? This case can be converted to a lower value. So the pair is 3, 19, 78. I will convert it to this pair. I will reduce 13 from B. So it will become 6 and I will add 7 to C. It will become 85 and I will put 9 for A. So this is the same pair. It will give us the same coefficient of X. Think about it. B is 6. That means you have 7 into 6, 42 plus 13 into 85. That will be the product. And here it was 7 into 19 plus 13 into 78. You can check that both the values will be same, right? So what we have understood so far is 7B plus 13C. We need the possible outputs of that, but it's not under any condition, without any restrictions. We can see that whenever B is greater than 13, we can convert it to a lower than 13 value also and get the same value of 7B plus 13C by adjusting the C value, right? So that helps us solve this problem because now our conditions are 0 is less than B less than 13 and we have B plus C is less than equal to 100 and we'll do case by case. So when B is 0, what are the possible values of C? C can be 0, 1, 2 till 100. So there are how many values here? 101 values. 101 pairs basically for B and C. Similarly, when B is 1, C can be 0, 1, 2 till 99 and there are 100 pairs here, right? Similarly, B is 2, C can be 0, 1, 2 till 98 and there are 99 pairs. And so on. Till B is 12, you can get C 0, 1, 2 till 88 and this will give us 89 pairs. So the number of pairs of B and C will be 101 plus 100 plus 99 and so on till 89. And you can calculate that by saying that there are 13 terms here. So 13 into 101 minus, we are assuming everyone is 101. So you'll subtract 0 plus 1 plus 2 plus 12, right? So this becomes 1313 minus 11 into 12, or 1 to 12, the sum of first 12 natural numbers is 12 into 13 by 2. So this becomes 12 into 13 by 2. So this is going to be equal to 78. So 1313 minus 78 is equal to 1235. So these are the number of pairs that are coming for B and C under these conditions. Now we also have to check whether all of these pairs give us different values of 7B plus 13C plus 7B, right? It should not be that any of the pairs inside this have same value of 13C plus 7B, right? So what I want to check is 13C plus 7B has different values for any B1 C1 and B2 C2 such that 0 is less than equal to B is less than 13 and B plus C is less than equal to 100. When you take two pairs in this range, you should always get different values of this expression. So let's check the values. If 13C1 plus 7B1 is same as 13C2 plus 7B2, if they are same, you can write it as 13C1 minus C2 is equal to 7B2 minus B1. But this implies, since 7 and 13 are co-prime, this means that B2 minus B1, 13 divides B2 minus B1. Or you can say B2 minus B1 is divisible by 13. However, our B's were in this range, right? B1 and B2 are both less than 13. The only way B2 minus B1 is divisible by 13 is if B2 minus B1 is equal to 0. And if B2 minus B1 is equal to 0, then B2 is equal to B1, which implies C2 is equal to C1, which implies these two pairs are actually the identical pairs. These two pairs have to be same. If the value of this is same, then these two pairs are the same. Basically, which means that if you take two different pairs, you get different values of 13C plus 7B. Now you have to convince yourself that any higher value, if B is bigger than 13, always you can convert it to a pair with B less than 13. We have already counted that there are 1235 pairs of B and C where 0 is less than B is less than 13 and B plus C is less than equal to 100. The values of A are very easy. Whatever is the B plus C value, A is the 100 minus B plus C, right? So we know the number of pairs here. We know that they give different values of 13B plus 7C, which means they give different powers of X, right? Different powers of X will come. So there will be 1235 terms with different powers of X. However, you need to check yourself whether if you take a different value of B bigger than 13, let's say B is 24, right? And C is 76. You should check that you can convert it to a lower value less than 13. So if you subtract 13 from this, you will get B is 11 and you add 7 to this. It will become 83, right? So you should check that 0, 24, 76 gives the same power of X as 1183. So 6, 11 and 83. It is an easy thing to check, right? So the answer for this is 1235 pairs. We had to use a little bit of multinomial theorem and also try to think of how to restrict the possible values of B. Because if there is no restriction, it is very difficult to count, right? So that's the solution for this problem. I hope you understood what we have done. And if you have any other questions, you can share it with me. I will try and solve it. Right. So that's it for this video. I'll see you next time.